Hello, everyone. So, uh, we were dealing with motion maps last time, and I'd kind of introduced those for the first time, and then I was telling everyone that the next class, next time you had class, there would be a quiz. And there was a list that I had had in that video about what kinds of things you needed to be able to do, like finding slope, uh, writing the equation of motion for a graph, uh, being able to use that equation, sketching a motion map, and we're even going to talk about describing motion using words. So hopefully that'll all make sense. But let me get myself over here a little bit so we can see the graph. Hopefully that'll make sense by the end of this little video. So what we did today. We did a bunch of examples here. I shouldn't say a bunch. I mean, we did a few examples of more of those kinds of things. And then we took a quiz. It's a 5-question quiz, a single graph with some information about the graph, and then some questions as well. So if you weren't here, that's what we did. With this graph right here, what I did is I sketched this graph, and then I said, okay, can you draw a motion map that works for this graph? And then I said that there are 3 basic things that we need to be able to identify and describe from a graph. And number 1 would be the starting position, because you need to know where to put your first dot on your motion map based on this graph and what it looks like. So starting position, direction of travel. So this graph tells us something about which way the object is moving. And so hopefully you remember what it is about that line that tells us that. And then the how fast or how slow part, the graph also tells us that, the how fast or how slow. Now, what is it about the line on the graph that tells us that? So again, we need to be able to translate what the graph looks like to what that means for motion. All right. So how do you know what the starting position is? Remember, it is the position at time 0. Time is 0 on the position axis. And so the y-intercept is the position when time is 0. So how do you know what the starting position is? Well, you look at the y-intercept. That is the position at time 0, when the clock starts. So what kind of y-intercept do we have here? Positive, right? It's above the 0, which means positive. Now, what direction is this thing moving? Well, what did we say about the direction from a graph? Remember, that's which way the line is tipped. Whether it's positive tipped or negative tipped, that tells us the direction. So in this case, what direction are we dealing with? That's a negative slope, right? So negative slope means negative direction. So we have a positive y-intercept. So the object starts with a positive position, but it's traveling with a negative, let's see, oh boy, wrong way. Oh gosh, how do I make this? There. Oh my gosh, I'm trying to draw. I'm trying to make my hand move in the same direction the line is going. It's a mirror. I'm seeing things backward. So anyway, that way. So that's a negative slope. That means negative direction. Now, how fast or slow? Well, we don't have any numbers here, so it's hard to tell exactly how fast or slow. And we only have one line on the graph, so I don't know. It's not really steep, but it's not level either. So I don't know. Maybe it's somewhere between fast and slow. But it is constant. So how fast or slow? Well, it's constant velocity because the slope is, or the steepness is, constant. So use that information to sketch a motion map. So actually do that now. If you haven't already sketched a motion map for this, hopefully you've already sketched this in your comp book. And then hopefully you've written these things down. And now you should pause the video and try to sketch a motion map. And then I'll show what that motion map should look like. Do that now. Let's see, I need to get my pen. Let's go with, oh, is that orange? Let's go red. Okay, so because it starts with a positive position here, I'm going to say it starts with a positive position. So on the right side of 0, remember, up and down on a motion map doesn't mean the same thing as up and down on a graph. All right? So what direction are my arrows going to have to be? What kind of slope do we have? Negative slope. So my arrows have to be negative, right? Oh, that way. So arrows are in the negative. Something like that. Now, did I draw enough? Did I draw enough arrows? Well, let's look what the graph shows. I started a certain position on the positive side away from 0. Yeah? Like here. That's how far. Now, how far did I finish? About the same, maybe a little more, maybe a little further away from 0 on the negative side than I was on the positive side. Do you see where I'm looking? I'm actually looking here. I'm kind of that. So this compared to this. So I'm on the negative side a little further than I was on the positive side at the beginning. So maybe I didn't draw these in, oh gosh, are they all separate? Let's see if I can move them all. Maybe I should move them this way a little bit. I mean, does it really matter? That's starting to get real picky about the details. So maybe I should have more arrow, like my last arrow should end further on the negative side than what my first dot started on the positive side. Hopefully that makes sense. Because again, I was further negative when I ended, when the line ended, than what it was when it started. So hopefully you see consistent arrow length means constant slope. The fact that they're pointed in the negative direction because it's a negative slope. The fact that it starts with a positive position, positive y-intercept. So that's telling us all the details. Now, how would you describe that in words? Well, again, you would be answering these 3 questions. Like in words, you would say the object, whatever it is, could be a cyclist, could be a runner, could be a walker, could be a car, could be a truck. I mean, whatever this thing is, the object, I would not call it it. Do not call it it, because I need to know what the it is that you're talking about. So the object starts in a positive position, traveling in the negative direction with a constant velocity. Those would be words that describe motion. Here's what you should not say. Do not say it starts up high and goes down. You're describing the line. Or it starts high and goes negative. Again, you're describing what the line is doing. I don't want a description of what the line looks like. I want a description of motion. So you have to translate what the line looks like into motion words. Again, knowing that the starting position is where the y-intercept is. So you would say it starts with a positive position, not that it starts high. What does that mean that it starts up high? It means it starts with a positive position. And when you say it goes down, what does that mean? That means it has a negative slope, and so it's traveling in the negative direction. Okay? So you need to be able to translate line description into motion language. That's what we're going for here. Okay? So that's one example here. Let me get this stuff out of the way. Then I put another one up here. I put a blue line here like that. And then I asked everybody, hey, can you sketch a motion map for this line on the graph? Again, looking at starting position, direction of travel, and then how fast or slow. So take a look at that one, pause, and try to sketch that on the motion map, and then I will come back and then tell you what it should probably look like. Do that, pause it, draw it. Now, the fact that the line is on the position axis here, the time axis, where is this object then? It is at the 0 position. How long? I'd say for a couple seconds at least. It was at the 0 position and it just stayed there. So what isn't it doing? Not even moving, because it doesn't have a slope at all. The slope is 0. That's no motion. It's at the 0 position and it stays there. So how do we show that on a motion map? With a dot, no arrow. Where? On, I need blue. I need blue. So on the 0 position. Now, how do we show that that happened for multiple seconds? Because this didn't just happen like one instant. This happened what seems like could be a couple different seconds. Then I'd put another dot, only I'd put it below the first dot because it's still on the 0 position. Still on the 0 position. So that happened for at least a couple seconds. That's what that multiple dots is telling people. Then what does it do? So after doing that for a couple seconds, then it begins to move. Begins to move how? What kind of slope is that? Positive slope means, again, we have a positive slope. Positive slope. That's a positive direction. Okay? So my arrows have to be what? In the positive direction. So direction of travel, positive. Now, how does the length of these arrows compare to the length of the red arrows? Is the blue one tipped more than the red one? Is it steeper? I'd say yeah, for sure. That blue line is way steeper than the red one. And if you're not sure, well, look at how far the red one goes in the same length of time that the blue one. The blue one goes from 0 all the way up to here. That's quite a bit of change in position. In that same length of time here, the red one goes from here to maybe here. From here to here. That means, let me make some marks so you see what I mean. The blue one goes from here to here. That's quite a far way here. The red one goes from here down to here. That's not nearly as far. Do you see the position? The position is how far it goes up and down on the graph. So the red line doesn't go as far as the blue line does in the same length of time. Again, I'm marking them here and here. In that same length of time, the blue one goes that far, and the red one goes that far. That means the blue one goes farther in the same length of time, which means more change in position. Now let me get some of this stuff out of the way. That's making a mess. So I would draw it like this. I would draw a couple arrows, longer than the red ones. I don't know, maybe 3. I don't know how many. Oh boy, I got a little wiggly. So that maybe would be my motion. Oh, I guess they're going uphill too. That would be my motion map for the blue line. The blue line gets further than the red one started. So the red one started here. The blue one goes past where the red one started. And so my arrows do the same thing. They go beyond where the red one first appeared on the motion map. So those are the kinds of things we have to be able to do. Translate from a graph to a motion map and also into words. Now, here's something else we did. So I have let me get me over in the corner. I have a graph here, which I want you to be able to sketch a motion map for, write the actual equation of the line. Remember, using position and time as our variables. Remember, those are the y and the x. The m and the b are our slope and the y-intercept. There's no numbers on this graph, so I'm going to have to give you that information, which I'll write up there on the board in a second. And then I want you to figure out where is the runner after or at a time of 8 seconds, after 8 seconds has gone by. So these are also the kinds of questions you're going to have to be able to answer on the quiz, and then of course the test that will be coming up after that. So let me give you a slope and a y-intercept here. Let's say that the slope is set. Oh gosh, I got to get my pen back. Let's say the slope is 7, and let's say the y-intercept is 4. So pause the video, look at this, sketch all this in your comp book, sketch a motion map, write out the equation of motion, and then use the equation to find out where. Remember, where is position, okay? Where is the runner? What is the position of the runner at time 8 seconds? So do all that, pause, do all that, and then watch the solution. So since the line starts above the 0, that means the object starts with a positive position, and in fact, a positive position of what? 4. For what? 4 meters, because again, position is measured in meters. So I need to draw a first dot on the positive side of 0. My first dot's going to be right here on the positive side of 0. And my arrow length, or my arrow direction, has to be what? Positive, because my slope is, positive. Slope's positive. I need to draw positive arrows. So I would do something like this. I don't necessarily care how long the arrows are. They just have to be in the positive direction, and they're all the same length because it's a constant velocity. How do we know it's a constant velocity? Because the line has a constant slope, constant arrows. Equation of motion. Again, the y equals mx plus b. What is the y variable? Position. You could use x as the symbol. I'll use the word position because that's what we've been doing. Position equals, what's the slope? Well, I told you the slope. It's 7. 7 what? Well, 7 meters for every second. 7 meters for every second. Times what? What's the x variable? Time. Plus what? The b, the y-intercept. What's the y-intercept? 4. For what? 4 meters. So that's your equation. Okay? Remember, numbers always have to have a unit of measure. Always have to have a unit of measure. Next question. Where is the runner at time 8 seconds? Where is position? Is the runner at time 8 seconds? So now I'm telling you, see, these two are variables. Position and time are variables. Now I'm telling you when, that's 8 seconds, that's time. And I want to know where, that's position, at a time of 8 seconds. So I'm hoping that you're seeing that you substituted 8 seconds in for where time is, and then you solve the mathematical equation. So we're looking at position equals 7 meters per second times 8 seconds. Plus, I can't forget about my 4 meters over there. Now, seconds over here cancels seconds in the bottom. And so I have 7 meters times 8. What's 7 meters times 8? 56 meters. But I can't forget about my 4 meters over here, which means my actual total position is 60 meters. So where is this person at 8 seconds? After 8 seconds has gone by, at a position of 60 meters. Now, is that how far the person went? No. How far the person went is 56. Ooh, oh boy. How far the person went is 56. 56 meters is how far, if you go 7 meters every second and you do that for 8 seconds, you will have gone 56 meters. I hope you get that. But that's not where you are. That's only where you are if you started where? At 0 position. Did this person start at 0 position? No. So where they are is how far they went plus where they started. And that's where we get and how we get the 60 meters. I hope that's making sense. So the first part here is how far you went. If you know how far you're going every second and you know how many seconds you've been doing that, then you can find out how far you went. Plus where you started. And one more here. So this one. Again, this graph looks similar, but it's a little different. And in fact, I'm going to say it is a 5 for a slope, and I'm going to say that it is a -2 for a y-intercept. So pause the video, sketch the motion map, write out the equation, use the equation. Oh, hit myself in the mouth. And then come back to the video, and I'll show you the solution. Go do that. All right, hopefully you did that. That is a negative y-intercept, a negative position starting. And so that means my first dot has to be on the negative side of my 0 line on the left. But it's a positive slope. Positive slope means positive arrows. So, and maybe they're a little shorter than the last set because, again, it's a little slower than it was before. I don't know. I don't know if I even drew them a different length or not. But that's what the motion map should look like, starting in a negative position, traveling in the positive direction with a constant velocity. Equation of the line. Position equals 5 what? Meters per second times time, my x variable, plus, now I've got a -2. -2 what? Meters. -2 meters. So that's my equation of the line or my equation of motion. Then you're supposed to, again, solve the question here. Where is the runner at time 8 seconds? And so again, I substitute 8 seconds in for my time. So position is 5 meters per second times how long it was happening, that's 8 seconds, plus -2 meters. -2 meters. So seconds on the 8 there cancels the second in the bottom, and I get 5 meters times 8. 5 meters times 8, which is 40 meters. Now, is that where the person is? No, I can't forget about my y-intercept plus a -2 equals what? 38 meters. So this, again, that's how far, 40 meters is how far the person went. If you're going 5 meters every second and you do that for 8 seconds, you will have gone 40 meters. That's how far you went. But that's not where you are. Where you are is how far you went plus where you started. And because the person started on the negative side of 0 by 2 meters, then the person can't be at 40 meters. They went 40 meters, but they're only at 38 total because they started behind the 0 by 2 meters. Hopefully that makes sense. So that's what you need to be able to do for the quiz. That's what we did in class for the quiz. And then, yeah, hopefully this makes sense. Now, how would you describe this in words? Well, again, I would say the person or the runner started with a negative position, traveled in a positive direction with a constant velocity of, you could even say 5 meters per second because that's the number that I gave you. So that's how this works. Hopefully that makes sense. If you have any questions, you can let me know. Until next time, stay safe out there.